Hi, and welcome to the Physics Channel. This is a lecture series on Struct Theory. And Struct Theory is a theory of the universe that takes us from before the universe, i.e. what we call nothing, to what we have now, which is the universe, which we call something. And this theory is a theoretical physics concept. So rather than, say, like with the LHC, the Large Hadron Collider, where we may take a proton and fire it around a ring, colliding it with other protons to then create interactions, and then measure those with detectors, and then try and formulate or extend our understanding of science and of physics and of how the world works and indeed how the universe works. This method is the other way round. It's saying we accept, so that's a potential falsity, or that's a potential problem with the theory, but we start by saying, or by accepting and making a postulate that there is such a thing as before our universe. And then from this, we mathematically derive, or we attempt to step by step mathematically derive, well, how do you get from nothing to something? And the only criteria that we apply to this way, or to this theory, and therefore this way of getting from, say, before the universe to the universe as it is now, is to say the simplest, we always look for the simplest way forwards. So what we end up with Struct Theory, which as the name suggests, structure is just an idea of how you get from nothing to some kind of a structure, is we end up with, say, a whole set of step-by-step mathematical derivations, and then we set to mirror that on what we observe in the universe. So then we look at, say, things like electro-magnetism, we look at, say, the standard model of physics, we look at, say, quantum mechanics, and then we see if this mathematical derivation matches, if I get another pen, if it matches exactly what we observe. And then if we tie the two together and they do match, then what we end up with is a whole new branch of applied physics or applied math that we can start looking for, and that then enables us to maybe to look towards new technologies. Now, the purpose of Struct Theory itself is the universe, and it is space exploration. So where I am driving this, and therefore where if you follow this course, the kind of areas you may want to explore with it is therefore towards space exploration, towards new types of propulsion units that may say that, for instance, could take us to Mars in timescales that are much more practical and therefore more realistic. It also addresses concepts of resource. So in our current society, with the population that we have on our planet, we certainly have certain resource constraints. So the whole purpose of this theory is to try and unlock avenues of new technologies that can expand our resource, that maybe can get us further out into the star systems, and therefore help with the advancement of human civilization. In this course on Struct Theory, we are going to start at the beginning, at something we call postulate 0, which considers what the definition of nothing is. And then from that, in a step-by-step manner, we're going to derive another principle, funny enough, called Principle 1, Postulate 1, which is a definition of what something actually is. And then basically from these two things, we then derive everything else. So in that sense, struct theory is a grand unified theory of everything, because from this we will be able to derive the standard model, we will be able to derive what gravity is, we will be able to derive what matter is, what charge is, what magnetic field is, what all the forces are. We will also derive a whole new set of forces, in fact an unlimited set of forces. Now struct theory is a theory of the universe, and as such branches out into a whole set of different areas. So in the first part of this lecture series, we're going to focus on the simplest level, because what we find with struct theory is that we start with nothing, from which we're going to derive something, and then what we will find is that this something matches the observations in today's physics experiments, so that we are able to qualify all the math derived from that nothing by observing that what we derive actually replicates or is a good representation of the world around us which we observe. And in struct theory, the getting from nothing to something uses a mathematical tool we will develop called expanded complex number theory. And expanded complex number theory is very much like complex number theory, except it is expanded. So what we mean by this is that in struct theory, we start with a postulate called absolute nothing, and to get something from absolute nothing, we find that the simplest mathematical way to get this is to have something we call two direct opposites. So that the something can be considered the 0 point between two direct opposites, and the nothing is the fact that the two direct opposites enter a state of, I suppose the most representative way to describe it is like a state of flow, so that over the entire integral of this flow, you get nothing. So it's under the understanding that there is no such thing as time here. So you're not integrating over a flow of time, because time does not exist. You're not integrating over a flow of... So the word flow itself is a bit misleading, because obviously we understand flow to be like a flowing river, and you measure it with a clock, and the river is moving through space, which is also predefined. So the idea nothing is an idea of no construct. So even a vacuum is something. Because if I take a vacuum pump and pull out all the air, and then say, well, what's in the middle of it? Well, there's a structure around it. You have to remove the vacuum pump, you have to remove the structure, you have to remove the entire universe, or you have to say, if this is the universe with the vacuum here and the vacuum pump, well, nothing is outside of the universe, it's not even in the universe. Hence, you have to be careful about what these definitions mean. But within struct theory, the most simplest concept of an existent point is a consideration of two direct opposites. So it's similar to an idea of antimatter and say matter, but in reality antimatter can be made from this and matter can be made from this, but it is a totally different concept to saying before you had the universe, you have before the universe, then you have the universe, and that we're saying, oh, maybe we had antimatter and we had matter, and then we ask the question, where did all the antimatter go? Well, that holds no concept within struct theory, because within struct theory we're saying every existent particle that we might consider is already made from direct opposites in union. And it's an important concept because we find, or we will find, that it doesn't just take two direct, you can have three direct opposites to make an existent particle. You can have 5 direct opposites to make an existent particle. And this is an unlimited series. So this is the concept of these levels I'm talking about. Because if you consider this as a level, and I'll just call that level 1, which is meaningless to struct theory, but it gives an idea for this representation. We're saying that the more familiar particle within struct theory, which we are much more familiar with in terms of current physics, where one can be considered plus, one can be considered minus, in terms of sign of the direct opposites. On level 3, that can be considered plus, that can be considered minus, that can be considered 0 for neutral, although it's not really neutral, but we will get into that later. And so these direct opposites on the quintic particle is plus, minus, 0, and I'll call them whatever, I'll make these up. But the important thing being that these are all direct opposites of each other. What we are going to find in the first part of this series is we are going to look at the simplest state, because this model, from this thing which we actually call a diop, which means two opposites, two direct opposites, where direct opposite means, it's a bit like, say, very loosely termed, an idea of, say, what we might consider positive and negative, but you have to be really wary because we haven't yet derived charge. What we will find is that from this, in this area just outside nothing, there's no such thing yet as time. There's no such thing as space, there's no such thing as mass, charge, no concepts of forces or anything. So therefore, using things that are derived further down the chain to explain things higher up the chain will be misleading. What we find with struct theory, which is a whole set of postulates derived from a first statement called absolute nothing, is that all the characteristics that you can mathematically derive from absolute nothing then imbue themselves on all the physics that we derive down the line. So in the sense, if two direct opposites enter a state of direct union and a state of oscillation, which precedes time itself, we haven't even got into the dimension of time, then everything that can be built from this will inherit those characteristics. So what we are saying is that we can derive charge from this, we can derive electric field from this, we can derive magnetic field from this. In fact, we will find that the diops allow us to derive leptons. And indeed, triops, as in 3 direct opposites, will allow us to derive quarks. So the simplest states are things that we have already observed in real physics. So I will call this real physics, and by real physics I mean maybe dimensional physics, because what we're going to find is that there is an area. So if we keep within the familiar area of physics, and maybe stay away a bit from the quintop, because the quintop is where we're going to start entering the realms of gravity and a whole bunch of forces that maybe we haven't explored as much. And certainly this expanded complex number theory is actually an expanded complex number series without limit. So we will talk about that in a little bit. But the first part of this lecture series is really to focus on leptons, because the maths of this is probably the easiest part. Once you start going into the higher dimensions of subspace, which I'll explain in a bit, this is where the math gets more and more complicated. So to cap the end of this section of the lecture series, we're going to say what we're looking at doing is to look at the first principle of a theory called Struct Theory, that takes us from a definition, a mathematical definition of what nothing actually means, to a mathematical definition of what something actually means. And then we're going to find that from this we derive something called a diop, which can be abbreviated to 2, 0, plus, minus, with a vector sign above it. And then we can explore the characteristics of this. But then what we will find is that from this diop, we then can derive through something called k-op interaction theory. So 2, 0, plus, minus means two things that come into existence, well, one thing that comes into existence through the appearance of two opposites. So those two opposites are intrinsically related, and so that they satisfy the basic premise that they don't exist. So that this one thing on its own, if you imagine there is no universe yet, and then this thing appears, well, it satisfies the fact there's nothing there, because there's no observer. There is, because until you have the appearance of another one, or another anything, then there is nothing to qualify the existence. And we give it a plus and minus sign through convention, because we historically understand a concept of a plus and a minus, and that if you combine a minus and a plus, well, it disappears to nothing. So we're essentially saying that if those transect that same 0 point, then suddenly that returns into what you could call the greyness of nothing. So you can perfectly have, outside of our own universe, nothing. And you can perfectly, or you can presume that within that nothing, that outside any notion of space and any notion of time, you can have a diop appear, but nobody will ever know it's there. It can appear there, and then it can disappear forever, or it can appear forever. It can do whatever you might want it or not want it to do. We will never interact with it, we'll never know it's there. So for all intents and purposes, we can ignore it. And then what we can say is that the universe is made up in a similar way. And the reason why we can say that the universe is here is because these are actually, or there is a set among these that are doing something. So you could imagine, you can quite happily say that there could be 100 times our universe of stuff that is not doing anything, that doesn't interact, so we ignore it. And it's only the stuff that actually is doing something that then becomes relevant. So from this diop and from these characteristics, what we will be doing is to derive an area of physics called subspace physics. And then from this area of subspace physics, we will then derive electromagnetism. And the different concepts between this point, the subspace point, and the electromagnetism point is that electromagnetism deals with familiar dimensions. It deals with things we know. It deals with a dimension of time, and it deals with dimensions of space. In fact, we will find through derivation that electromagnetism is actually a two-dimensional form of wave propagation, which is important, especially when it comes to diffraction patterns. And especially when it comes to our understanding of what the speed of light is and how fast waves can travel. And then subspace physics, which derives directly from the diop, deals with the physics of what is going on in this particle. Because as we were saying, there's no concept of time to this, there's no concept of length to this, so there's no concept of mass, there's no concept of charge. This is a foreign entity in terms of physics understanding. But what we will find is that through very basic step-by-step mathematical derivation, that the physics of a diop is actually governed by something called subtime. And in fact, we will find subtime to be quantized. And from subtime, that we also branch off into another area of physics, which is dimensions of time. And from subtime, we find that subtime itself is quantized, and that is a precursor from which we can derive quantum mechanics, of which that also has significant implication because it changes the understanding of how you can apply the math to building things. Because the fact that time itself is what is quantized, as opposed to, say, space, changes what we can do. Okay, so that ends the first part of this. What I'm going to do now is I just want to talk a bit about this expanded complex number theory. So, as the name suggests, expanded complex number theory is complex numbers, but expanded. So why do we need this theory, and what's it about? Well, firstly, it's a math theory, so it's just a mathematical tool, and it's created to allow us to explain what's going on at the diop level, so at two opposites level, what's going on at three opposites level, what's going on at 5, 7, 11, etc. So complex numbers, or traditional complex numbers, that is used in to define electromagnetic wave propagation, in fact, and it's certainly used in various field theories, etc. It is a standard, I think it's C is equal to X, which is a real number, plus I, Y, where I is an imaginary number, again, we use the caveat that the term imaginary can be, again, a bit misleading because it's not imaginary in the sense that light waves are real. We can see them, we can use them, they do stuff, and we can use this math to define it. So when we draw up an organogram diagram, where we put in an angle and we have our imaginary axis and we have our real axis, and then we use this to explain certain types of fields, wave propagation, etc. Well, it is stuff that we can measure and it's stuff we can use. Now, expanded complex number theory has got nothing to do with real space. It is the math of subspace, i.e. the math of where there is, of the stuff inside the space. So, when we look at a diop, where we can have a plus and a minus, and we can symbolise it in terms of, say, this, 2, 0, plus, minus, where 0 just means 0 points. So what may be another diop or another chaop, where chaop is just, say, a general word for any type of existent particle that comes out of absolute nothing, as far as an interaction is concerned, or as far as something happening between a 2, 0, which, say, could be argued as maybe a point of origin, and a 2, 1, plus minus, which could be argued as another one that appears, well, as far as considering a subspace physics interaction between these two things, we classify it as happening between this point and that point, as opposed to these. And so for this diop, we can create a complex number of subscript 2 to represent that we're talking about two direct opposites. And then we use the formula, this complex number is equal to jx plus I, y. Okay? And the I is the familiar, or has a certain familiarity in terms of being a square root of -1. But the j is the other direct opposite, the square root of +1. So we can see that in terms of relation between complex number theory and expanded complex number theory, then at the simplest echelon of expanded complex number theory, you could simplify C is equal to square root of +1x plus square root of -1y to C2 is equal to x plus iy, which is the equation we've got up here. And the reason why why we're going through this here is because it's not by accident that we've been talking about we can derive electromagnetic propagation from the 2-op. So I call it a diop, but I also call it a 2-op, because what we'll find is, as we get further into other lecture series, when we start dealing with 11-ops, it'll be easier just to use the number terminology. Because struct theory, or from struct theory, we derive something called chaop theory, which is what this begins. And then from chaop theory, we can derive chaop interaction theory. But more importantly, chaop theory is a divergent prime number wave function. It's an expanded complex number prime number divergent wave function, which is one formula which is a theory of, or is a grand unified theory of everything, that explains all the forces in the universe and predicts an unlimited number of additional forces or additional dimensions, etc. We will be deriving a summation series, an expanded complex number summation series that simplifies to a prime number solution of space and time, and that is also linked to a time series and to unlimited dimensions of time as well. But that is getting way ahead of ourselves. Where we start here is just the basic understanding that it is not by accident that the complex number, that we can use the basic x plus iy complex number in electromagnetism, because we have a more fundamental, or it's a simplification of a more fundamental mathematical derivation. And so, just to push this a little bit further, because there's a relationship between, say, a 2-op, which is the diop, yeah, two opposites, and a triop, or a 3-op, which is 3 opposites, and I'll even put on here for now the quintop, or a 5-op, and 5 direct opposites. Paying attention to the recognisable plus and negative for the 2 opposites, plus and negative and 0, which I'm going to call neutral, and the quintop. The reason I leave the quintop in here is because this is how we start getting towards gravity and explaining a whole set of new forces which we can technologically apply to start furthering human advancements in a way that is going to be a lot more useful to society. So I'll leave this in there. We've got plus, minus, 0. I think I put that a hat and a T. I just made this up. What we'll find is we may start, when we get into the higher dimensionalities, we may start using a number system for those opposites as well. But the triop, in expanded complex number theory, quite simply can be written as complex number 3 is going to be equal to j, which is plus 1. So we've got the plus, yeah, as equivalent to that plus. Tick those off. So jx plus iy, which is the square root of minus 1. Again, the familiar minus, yeah. Plus k z. So this again, this is in subspace, because as long as we only have one existent particle or one existent thing of 0 size called a 3-op or triop or whatever you want to call it, then there's no concept of time to this, there's no concept of space to this. You need a certain number of these things to then start being able to define a concept of space or a concept of time. You know, and it extends, or it follows very closely with relativity and frames of reference and understanding. This is why this is called struct theory, because the whole concept of the struct is very much that if you start with nothing and then you get to something, then whatever makes that something defines a structure, it gives structure to that something. So therefore the concepts, or the dimension of time, the dimension of space, the measure of mass or charge that we eventually measure further down the chain, are intrinsically derived and brought about by these things. So they often lower down the pecking order. So what we have then is the 3-op is a free axis, in a sense, I suppose you could call it, in terms of symmetry. Mathematical definition, with this being root of neutral 1. And then the quintop is C5, and for the quintop I change the notation to 1 hat big 1 plus 2 hat big 2, plus 3 hat, big 3, plus 4 hat, big 4, plus 5 hat, big 5. And this is a notational convention because for an 11 op, we're going to have 11 orders of axis, etc. So within this first part of the lecture series, we are going to focus on the derivation of electromagnetism, and we will find that we can derive electromagnetism from the 2-op. In fact, we can derive all leptons in the standard model from the 2-op and all the combinations we can have thereof. And then we will find that in the next series, where the math begins to get a bit more complicated, as now we are dealing with 3 axes, we will find that this derives the quartz model. We can derive quartz. We can derive basically the nucleus of the atom. And so that therefore the combination of these two, we can define chemistry. Now I say that loosely because really what we are saying is that the universe is already here. Everything is already here, it's already done. So the only thing that stops us, say, getting to Mars in a 1 minute journey, is our lack of understanding. But the means to do all of this is already here, because the universe is here, it's already finished. So our current understanding, say, of how the atom works, of how certain things work, is always going to be limited. Even if with this we can branch out to other areas, that is still always going to be limited. We are always going to, with time, assuming that, that through fortune humans are still around, that through time we will find, more and more fundamental truths that can help advancement. The fact will always remain that we are always in a limited form compared to the universe, which is finished in its full splendour and which is already done. So what I'm trying to say is my focus has solely been on looking at the most fundamental aspects possible, coming up with struct theory and then mapping that out. But that in itself is also a journey. And it's very possible, and it's not something I've yet had time to look at, it's very possible that the C7, the C11, the C13, that all of these are in the same atom, and that we're nowhere near yet knowing that. But having said that, it's also very possible that all these other type of interactions happen at happen actually on different scales. I would strongly suggest that the way that the way of galaxy formations, the way the spiralization of galaxies, the actual dimensionality of the universe itself, from this theory we do find that not only do we derive therefore this concept or this area, for lack of a better word, of subspace physics, but we find our unlimited dimensions. So if we are currently limiting our blinders to just a 4D space-time view of things, then we are cutting out very close to an unlimited amount of the universe. It is very much like saying, well, if the universe is this big, and if we say the universe comes from nothing, and we have limited ourselves pretty much by the looks of it so far to just the 2 rungs of the ladder, and we're saying there's an unlimited number of rungs of the ladder, and that would be the representation of the universe, then we can quite confidently say that if this is 0, that we are very close to 0 in our understanding of everything. And therefore we are very close to 0 in what we can do relative to everything. And so this is what this course is about. It's in the first step, if we are able, which we will do through this course, if we derive electromagnetism from a fundamental theory, then we are tying law, or a basic fundamental law, with what we know to be true, or what we've observed and proven through experiments. If then we simultaneously are able to derive the nuclear forces and the quark model through the next rung in the ladder, then it puts us in a very strong position to assume or to have confidence that all the other steps, all the other rungs are also true. Because from a mathematical point of view, we are able to derive an unlimited, divergent, expanded complex number prime number series. You can even use something called proof by induction to prove if it's true for one, we can prove it for all of them. And we can end up with one formula that will allow us to build constructs. And the main aim, I would say there's a few aims, but the main aim of struct theory is to advance technology, is to overcome our current resource issues. With struct theory, we'll be able to create things like subspace drives, which are forms of propulsion that can take us to other stars in what I'd call linear time, so where you could call it common time, what we recognise as being a linear type of time through which, say, our generations live. So in that kind of a concept which we are familiar with, we will be able to travel to other stars using new types of propulsion units that can be created based on these physics, that can get us to habitable worlds within short periods of time. Other aspects of this is, which we will explore to, and we certainly will go quite in depth into with these two ops, is something called subtime. So within subspace physics, we find that to satisfy this law of non-existence, or this law of absolute nothing, that the two opposites, they enter some kind of a state of flux. I mean, in fact, this whole concept of wave-particle duality, which we see later on, and this whole concept of quantum mechanics derives from this fundamental thing with regards to symmetry. In the formula itself, when we start defining how the opposites flow about a 0 point over the integral of the entire set, for that to happen, it oscillates, and without a concept of time, it moves about the 0 point in an unlimited fashion, and that unlimited fashion is quantized, and that quantization is something called subtime. Each direct opposite oscillate through something called phasic subtime, where they have their own phase, and the overall quantization of this particle is actually the quantization of subtime, as opposed to any concept of length. Because what we are going to see is when we introduce another direct opposite, that's when we can then we end up with 2 points of conceptual existence, and that's when we can start deriving dimension. Because it's only once you have another point, or another point to qualify the first point, and that you can consider a ratio between those 2 points, that then you can consider through geometry these ideas of what length is.